So page 29, we're applying more of the rules. It's just a matter of identifying the u. Alright, so that's my u. U prime goes up top. I got a 3 in front though, so let me hang on to that. 3 times u prime, which is going to be the 5, over the square root of 1 minus u squared. So 15 over the square root of 1 minus 25x squared. Alright, so that's not too bad. The next one, though, is bad. Now, the next one involves a little quotient rule. So we'll just kind of get this into the setup, and then after that we'll see where we end up. Alright, so we're looking for dy dx. So quotient rule, we have the bottom squared, denominator times the derivative of the numerator, which I'm just going to write as d dx of arc sine 2x for now, minus high d low, or numerator times the derivative of the denominator. So arc sine of 2x times the derivative of the denominator is just a 1, so we'll just leave that alone. So now I just got to take the derivative of this piece. Now the u here has a derivative of 2. So 2 over the square root of 1 minus 4x squared. I'm going to multiply that by the x. And then really everything else is just coming along for the ride. Alright, I mean, there is some more housekeeping that could be done, but if it doesn't really serve a purpose, then there's no need to get into it. I mean, we could get common denominators and stuff, but I don't see how anything's going to simplify. So we'll leave it at that. Now, number 3, we have secant of the arctan, so a little u substitution, chain rule. So q prime secant of, well, my inner function is arctangent, so we'll hang on to that. So secant has a derivative of secant tangent, so secant of the inner function, tangent of the inner function, multiplied by the derivative of the inner function. So that inner function again is arctan of x so I'm going to just kind of smidge this over a smidge, resize it, bring it in. Now I just need to be able to figure out what the derivative of the arctangent of x is. Fortunately, that's exactly one of our rules. Alright, so that is 1 over the square root of 1 plus x. Oh, actually, not the square root. Force of habit. 1 over 1 plus x squared. Now, tangent of arctan of x is kind of a nice little development here. Cancels to just an x. So we're going to have secant of arctan of x multiplied by x over 1 plus x squared. Now it's just a question of, all right, is there any value in trying to clean this one up? Well, let's see. Draw a triangle. theta here. So this is my ratio, opposite over adjacent, the square root of 1 plus x squared. All right. So the secant ratio, hypotenuse over adjacent, is going to be the square root of 1 plus x squared. So that's multiplied by this whole thing. So it actually will clean up a little bit more. All right. So that square root of 1 plus x squared could also be thought of as 1 plus x squared to the 1/2 power. Put it together with the other fraction, and you have a little keep the base, add the exponents action going on here. Alright, but I'm going to rewrite this bottom as 1 plus x squared to the 1st power to make it a little bit more obvious. If you keep the base and subtract your exponents, you get x times 1 plus x squared to the negative 1/2 power. And that's a whole lot cleaner than what we started with. Alright, so definitely, probably, possibly worth the time. Alright. I only say that because you don't know what the purpose behind the question is, and that's something hopefully that you picked up in pre-calc, calc 1. Basically everything after algebra, because in algebra it's like you're learning the skills for the sake of learning the skills, but in the courses that follow, hopefully it's been like, all right, now why would you simplify? What's the purpose? What's the benefit? Is there a benefit? If not, then don't do it. If so, then absolutely do it. All right. So just keep all that in mind when you tackle a problem. All right. The last one here looks like a product. So h prime is going to be first times the derivative of the second plus the second times the derivative of the first. Alright, so plus arctan of x squared times derivative of the first is the 2x. Alright, derivative of arctan x squared, well, we know what our u is. So 2x over 1 plus u squared, so x to the 4th multiplied by the x squared plus 2x arctan x squared. Alright, so it looks like the only thing that we really can do here is combine the x squared with the fraction to make a 2x to the 3rd power is what I meant to write. There. And there we go. Yeah, because there's no way to simplify the arctan of x squared without knowing what x is, so, and without getting into other coordinate systems, so we just leave it at that.